Okay, this is screencast 5. So today we're just going to work through the problem of finding the Laplace transformation of f of t equals piecewise function 0, where 0 is less than t, where t is more than 0 or less than 3, and t minus 3, where t is more than or equal to 3. So first we're going to have the standard function for the Laplace transformation that we're going to work with, where it's 0 to infinity the integral and f of t times e to the negative st d of t. So that's going to be our function that we're going to start off with, and we're going to plug in the piecewise function into it. So we're going to get the integral of 0 to 3, where t is from 0 to 3, of t minus 3 e to the negative st d of t, plus for t minus 3, 3 to the to infinity, the integral of that, and t minus 3 e to the negative st d of t. So these two things are going to represent what we plugged in from the piecewise function. So the first thing we're going to do is we're going to cancel out the integral of 0 to 3 by taking t minus 3, where 3 minus 3 equals 0. So f of t equals 0 there. We want it to all to be to infinity, because we know that from 0 to 3, t equals 0. So it's from t onwards. So we're just going to be working with that t minus 3. So we're left with the integral of 3 to the infinity e to the negative st t minus 3 d of t. So now that we got rid of that first part and made that 0, and now we're left with everything to infinity, we're going to integrate it by parts. So we're going to take these step functions where u equals t minus 3, d of u for that is d of t, and we're going to take, we have d of e where it's e to the negative st, so we're going to integrate that and get negative e to the negative st over s. So we're going to finalize it by having our integration equation where t minus 3 times negative e to the negative st over s, 3 to the infinity, times the integral of plus 1 over s, e to the negative st d of t. So that equation is going to look like this when you work it out, where the negative limit of t to the infinity is t minus 3 e to the negative st over 3 plus 3 minus 3 times negative e to the negative 3s over s minus 1 over s squared e to the negative st 3 to infinity. So all of this is going to represent your transformation from 3 to infinity, because remember, we got rid of a 0 to 3 equals 0. So we're just going to, the transformation equation is just going to look like this, where from 3 to infinity, this is where the transformation is really taking place. So this part right here, which I have did this underline, that's going to cancel out to get 0. And then we're going to be, because t minus 3 plus 3 minus 3, the 3 minus 3 makes 0, so it cancels out. And then we're left with negative over 1 times, negative 1 over s squared e to the negative st, 3 to infinity, and then we're going to get negative limit t to the infinity 1 over s squared e to the negative st plus 1 over s squared e to the negative 3s, because that's what it looks like when you integrate everything. So that gives us 1 over s squared times e to the negative 3s. So from here, it's pretty simple, just 1 over s squared times, just take e to the negative 3s over 1, and then you get e to the negative 3 of s over s squared. So the Laplace transformation of f of t is going to equal e to the negative 3s over s squared. And that is your Laplace transformation for this piecewise function, where it has it from 0, from t equaling 0 to 3, and t minus 3, where t is more than or equal to 3. And for the graph, this is what the graph represents, where the green and blue lines represent the piecewise function, and the red line represents your Laplace transformation. So I hope this was helpful, and I hope this gave you a general idea of what you're supposed to do and the steps you're supposed to take when you're solving a Laplace transformation of a piecewise function. Remember, you start with plugging in both equations into your standard function, canceling it out to where you just have everything to be to infinity. Then you integrate it by parts with your step functions. Then you cancel out where you can, and then you're left with your equation that's left, and then you just multiply it out, and then you get your answer.